So, let's dive into the mind of a true giant, Sir Isaac Newton. We're talking about a man born way back in 1643 who didn't just study the universe, he pretty much wrote the rulebook for it. And believe me, that changed everything. Okay, so you've probably heard the classic story, right? Newton, chilling under a tree, and bam, an apple falls. For most of us, that's just, well, an apple falling. But for a mind like Newton's, it was a massive question mark. What on earth was this invisible force that just pulled it straight down? And that one little moment of curiosity, it literally sparked a revolution. But here's the thing. The apple is just the appetizer. It's just the beginning of the story. Newton's genius went way, way beyond gravity. We're talking about the secrets of light, and even inventing a whole new kind of math to describe the universe. All right, so let's break it down. We're going to look at the three huge pillars of his work. These are the ideas that didn't just make him a great thinker, they built the foundation for pretty much all of modern science. First up, his most famous contribution, the laws of the universe, or basically, how everything moves. See, Newton was on a mission. He wanted to find a single set of rules that could explain it all, from that apple falling off a branch to the planets circling the sun. And this is where it gets really mind-blowing. The big idea was universal gravitation. It wasn't just that the Earth pulled on the apple. No, Newton realized that every single thing in the universe is pulling on every other thing. The moon pulls on the Earth, the sun pulls on us, you're even pulling on the device you're using right now. It's like this giant cosmic dance, and Newton was the first one to figure out the choreography. So in 1687, he drops this absolute masterpiece on the world, the Principia Mathematica. And look, this wasn't just another book. This was the blueprint for classical physics. It was a complete system for how the world works, and it stayed the undisputed champion of science for more than 200 years. Just think about that. And inside this book were his legendary 3 laws of motion. You've definitely heard of these. Law number 1, the law of inertia. Basically, stuff keeps doing what it's doing unless you mess with it. Law number 2 is all about force, mass, and acceleration. You probably know it as F equals ma. And number 3, for every action, there's an equal and opposite reaction. Just 3 simple rules, and they explain, well, pretty much everything. But Newton wasn't done, not even close. His curiosity was unstoppable. After tackling motion, he turned his sights to light itself. He wanted to figure out the secrets of the rainbow, to really understand what light even is. And the way he did it was just so elegant. He took a simple prism, went into a dark room, and showed the world something incredible. He proved that the white sunlight we see isn't pure at all. Nope, it's actually a mix, a beautiful blend of all the colors of the spectrum. He literally unraveled a rainbow. Now, this wasn't just a cool party trick. This discovery had a huge practical impact. See, the telescopes of his day used lenses, and those lenses would bend light in weird ways, causing colors to get all distorted and blurry. Newton thought, wait a minute, and came up with a brilliant fix. He designed a telescope that used mirrors instead of lenses. The mirrors reflected all the colors perfectly, giving a way sharper, clearer view of the stars. It was a total game changer for astronomy. And guess what? We still use his design today. Okay, so Newton has figured out the laws of motion and the secrets of light. But there was a problem. To actually describe a universe that's always in motion, with planets moving and things speeding up and slowing down, the math of his day just wasn't cutting it. He needed a brand new language. So he just invented one. And that new language, it was calculus. Now hold on, don't let that word scare you off. At its core, calculus is simply the math of change. It's this incredibly powerful tool that lets us understand things that are moving by kind of hitting a pause button on incredibly tiny moments in time. You analyze those little snapshots, and you can understand the whole picture, whether it's the orbit of a planet or how fast something is growing. And having this new mathematical language, it unlocked a whole new world. Suddenly, with calculus, we could precisely map planetary orbits. We could really dig into the details of speed and acceleration. It laid the foundation for pretty much all modern engineering. In short, Newton gave us the ability to measure change itself. But Newton's story doesn't just end with his scientific discoveries. His impact went way beyond the lab. His genius earned him so much respect that in his later years, he became this huge figure in British society, and he started using that incredible mind for public service. So, after he published his masterpiece, he wasn't just a scientist anymore. he took on some really big jobs. He became the master of the mint, where he used his scientific brain to overhaul England's entire currency system. And for more than 20 years, he was the president of the Royal Society, basically steering the ship for all of British science. He became the very symbol of genius. When you really think about it, Newton's legacy is, well, it's everywhere. It's woven into the very fabric of science. He gave us a complete framework for understanding the physical world. It was so powerful that it completely changed how we see our place in the universe. He didn't just watch the world happen, he gave us the instruction manual. And for all these incredible achievements, he was also surprisingly humble. He knew that science isn't a one-man show, it's built up over centuries. His famous quote says it all. "If I have seen further, it is by standing on the shoulders of giants." He understood he was part of something much bigger than himself. So Newton gave us the universe's rulebook, or at least the rulebook as he understood it. But you gotta remember, that was more than 300 years ago. And it makes you wonder, right? In a cosmos that's still packed with so many mysteries, what other rules are still out there, just waiting for the next Newton to come along and find them?